Oh, okay, cool. So shall we start?
Yeah, I'm waiting for you.
Okay. I'm doing some upgrade in my system. So that's also going in parallel.
Okay, that's fine.
I'm opening. Oh, oh, fine. I'm sharing my screen.
Okay.
Able to see?
Yes.
Okay. And then I think that. And this all we have covered. Okay. Now I think we need to start with the Hadoop ecosystem,
Okay.
right? So, okay. So far, any question, any doubt you have?
No.
Hmm, fine. So let us start with Hadoop ecosystem. So as we understood, Hadoop is just one single component. Okay. So what happened? Each company have taken this Hadoop as a base Hadoop and customized as per their requirement and inbuilt or built a tool on the top of the base Hadoop. Okay. So integration of those components called as a Hadoop ecosystem. Okay, where we have multiple software or multiple framework tool are working together and creating a complete ecosystem. Okay. As we know that Hadoop can handle the complete data lake. The data can be of any type, the source can be of anything. So according to your requirement, you can have the solution. So just like if you have the log data, so you can use a Flume. Okay. So this component you can use for your data ingestion. Suppose you are working with some RDBMS. Okay. You have, let's say, DB2 or Oracle. Okay. And you want to ingest the data. So in that case, you can go for the Sqoop. That component you can use. Okay. Similarly goes for HBase. If you are working with any NoSQL database, you can go to the HBase. If you want to work with uh, like SQL query based system, you can go with the Hive. Pig, Oozie is complete for the complete workflow. Zookeeper is for soft coordination of the services. Okay, like that. And here we have a base HDFS as a file storage, and Ambari is a complete. Uh, Ambari is a complete monitoring tool. Okay, clear on this? It's a very basic.
Yeah.
Okay.
Okay.
So yeah, so just go through this slide once. Okay, whatever given in upper mentioned here. It's like different requirement and every solution in based on a different component we have. When you are done, let me know.
Yeah, you can proceed.
Okay, fine. Okay, so this is the difference between, because so far most of the people have worked on the traditional system, just like the RDBMS, but now we want to see the difference between the RDBMS system and the Hadoop system or the big data system. Okay, so please have a look and just compare this RDBMS versus Hadoop. So based upon this bullet points, please have a difference. Just have a look on the slide, then we will discuss. So it's like the data type. In RDBMS, we have a structured data, but in Hadoop, we have a multiple format of data: structured, unstructured, and semi-structured. Here, one correction: write are slow here, not the fast. Okay.
Okay.
In Hadoop, the writes are slow. Done with this slide?
Yeah, can go ahead.
Okay. Okay. So hope you understand what is mean by processing here. Process coupled with data. So do you understand this term? What is mean by process coupled with data? Would you like to explain this?
Limited no data processing coupled with data. If I understand correctly, I'm not sure actually.
In that case, you should ask me this question.
You should explain it for me, Abhishek.
No. When I ask you any question, you should say, okay, I do have questions here. Okay, I am asking you to read so that you can remember this. Definitely, I'm going to explain you everything. Okay, but why I'm asking you to asking you the question so that you also can be attentive. Okay, because it will gonna be a discussion base. If you don't understand, simply say, I want answer for this. Okay,
Yeah,
got it?
I think this one is coupled with data. That means it's like connected. It's working together with data.
Okay, don't worry. I explain it. But what I'm telling you, whenever I ask you to read the slide, okay, just read it and then I ask if you have any question. Okay, if you don't have, then definitely I'm going to explain that slide. Okay, I give some time to read the slide. Okay, fine. So let's go one by one. So data type we understood. It have a multiple structure of data: semi-structured, unstructured, and structured. Okay, in RDBMS we have only the structured set of data. Okay, when let's talk about the processing, how we do the processing in RDBMS system. Okay, it's no data processing, right? Data will be available on its place only. It's a process. It will rotate. That will traverse to the system. But when it's come to the Hadoop system, process coupled with data. So you remember we have created a one cluster with 4 nodes, right?
Yeah.
And we have distributed the data on first and the third node. Right? So whenever I do any process, so my job will run on the first and the third node only. So wherever the data lies, my job will execute on that particular node only. Okay. So that concept was as a processing coupled with data. So it will reduce my data traversing actually. Clear on this?
Mm-hmm.
Are you clear on this? Any question or any doubt, confusion?
Yeah.
Okay. There is a one term called as a data locality that we will understand in detail. Okay. It's similar to that. This only data coupled with process. Okay. Fine. Going to the next, governance. So when it's come to the RDBMS, because RDBMS is pretty mature, okay, so it have many governance compliance, okay, but when it's come to the Hadoop system, so we do not have that much secure governance with the Hadoop system. Okay, nowadays there are many company like Hortonworks or the Cloudera, they introduce with some tool called as the Atlas or the Falcon. With that, they are giving with the governance. Otherwise, we do not have very structured or definite governance in Hadoop system. Okay, clear on this?
Mm-hmm.
Now the next is schema. So obviously we know in RDBMS, we require the schema for the writing also, write and read. For both, we require the schema, correct? But in Hadoop system, for writing, we do not require the schema. It's not mandatory for writing. But for reading, we require the schema. Okay. Now, talk about the speed. Here, read are fast, but here writes are slow actually. Let me write it. Write is slow in execution. Any idea about this? Why write are slow? As compared to the read.
Let me start from the other one. The other one, the RDBMS. So RDBMS reads us fast because it's defined. It is the schema is defined in a tabular format, and this, and it is stored in a certain place. But but on Hadoop structure, it because it is not structured or
not exactly.
I think I'm guessing that.
Not exactly. Okay, but in the Hadoop system, read are fast. Let's talk about the Hadoop system only. If you compare
Hadoop system read are fast.
Yes, Hadoop read are fast, but writes are slow.
Okay, I thought read is fast in RDBMS.
No. Okay, but why so? Okay, I will explain you in our HDFS component how Hadoop has been designed. There you will understand. But for now, just remember, read will happen in parallel.
Oh yeah.
Okay, but write happen in sequential.
Oh, okay.
Okay, we will see how exactly what is the read and write anatomy, okay, in our HDFS. In detail, we also see. But for now, just remember that read happens in parallel mode, write happens in sequential mode. That's why write are slow.
Okay.
Okay. Good. Fine. Now going to the next, cost. So obviously RDBMS system is pretty costly. Okay, you have to buy or you have to purchase the license, right? So whenever you want to change your system or upgrade your system, you have to bear a lot of cost. But when it's come to the Hadoop system, it's a freeware software. So you don't have to purchase it, you don't have to pay anything. But for the support and the maintenance only, you have to pay. Okay, but for RDBMS system, for purchase, you have to pay as well as for support and the maintenance. For both, you have to pay. Clear on this cost? Okay. Now coming to the resources. This is the data resource. Where from you are receiving the data. In RDBMS system, we only have the structured data. So mostly we know where from we are receiving the data. Right? But
Yeah.
it's one, but when it's come to the Hadoop system, so Hadoop can handle your structured data, unstructured data, semi-structured data, right? You can have the data, streaming data also, log data also, batch data also. So like, it's like data can come from anywhere. The data source can be anything. So that's why it is really complex and wide. Okay, clear on this? Resources, data resource.
Yeah.
Now, best in fit you. Because in RDBMS, we are dealing with less amount of data. So this is good for OLTP sort of system. Okay, or sometime OLAP. Okay, but Hadoop system is always for OLAP system. I hope you understand what is OLAP and OLTP system, OLTP and OLAP. Do you understand?
I think ordain transactional processing or something.
Yes. And what is OLAP?
That is analytical processing.
Correct. So I'm just writing it's for less data volume. Okay. OLAP we do for huge data volume. Okay. So Hadoop is good for OLAP system only. Okay. And RDBMS can go with OLAP and OLTP both. Okay. Clear on this? Okay. Any question, doubt on this slide? Okay. Good. So going to the next. Okay. Now the next is characteristics of Hadoop system. So these we have all things. So I want you to read this slide, then I will explain it.
Okay.
Okay. So what here we are saying that is the Hadoop system facilitates the storage, the processing of large amount of data. Okay, that we know, right? It's deal with the structured, semi-structured, and non-structured data. Now let's talk about its features one by one. It's a high scalable and available. Right? So what does mean? Today, scalability means the same thing which we discussed, scaling up and the scaling down. Okay, let me create a diagram for you. Okay, I'm creating the same cluster. This is my master node. I have a 4 data or slave nodes. Okay. The master node is connected to my slave node. Okay, now it's a high scalable and availability should be very high. What does it mean? Suppose today you are using 4 node of cluster. This is, let's say, node 1, 2, 3, and 4. Okay. So what does that mean? Suppose today you are using 4 node of cluster. Your data requirement has been increased. Now you require 5th node also. Okay. So how we do in the Hadoop? If you go to any RDBMS system, it's a really lengthy and the cost-effective process. But how we do in the Hadoop? Let's say if I want to add data node 5 to my system, what I will do? I will take my system into a safe mode. Okay. Take your system into a safe mode, or the cluster into safe mode, and then simply provide your IP address to master node. And that's it. And then again, take your system into active mode, and that's it. Now you have scaled up your system. Okay. So that's easy process we have into the Hadoop system whenever I want to scale up or scale down my cluster. Clear on this?
Yes.
Okay. Now availability, definitely we are working into a multiple geographical location on distributed cluster we are using. So my data should be available all the time for every user. Okay. Next is commodity hardware. So it's a cheap hardware, like low cost hardware. On that also your Hadoop system can work, just like your PC also, your personal laptop, that also can be used. Next is fault tolerant. So fault tolerant means whenever there is any failure, okay, so my system should be smart enough, it will handle that fault and it should not impact my existing jobs. Okay, example, let's suppose there is a job working on this node 2. I'm writing this as a J1. It's a job 1. Clear? It's running on node 2. Let's say by any chance this node is down. Okay, so what do you think? What will happen in that case? There is a job 1 running on the node 2, and due to any reason, the node 2 is down. It's not alive now. So what will happen in this case?
It will do it on other nodes.
Absolutely. What will happen? My system should be smart enough that this job will move to other node. Okay. Yes. So now my job 1, J1 job will start running on my node 3. So that sort of fault tolerance my system should have. Okay. Clear on this? Cool. Okay. Now move computation rather than data. Okay. So that concept called as a data locality, and it's really very important characteristic of Hadoop. What we say here, move computation, or let's say process, instead of. So what do you understand about by this line? Would you like to explain?
I mean, the data stays there,
Mhm.
but only the processing is done on other nodes.
Okay. And so what is the benefit we will get by data locality?
The place where the data resides?
Hmm. So is there any benefit or what benefit we will get by data locality?
I would say it's cost-wise. If you have to move it to somewhere else.
Hello. Hello.
Yes, I'm here.
Yeah, yeah. So any idea what benefit we can get by data locality?
I would say it's a cost
That's okay.
or security.
Not the security.
Those are the two I can come up with.
Just think little more.
No, that's it.
Okay, no worries. Okay. In big data system, I know we deal with a huge amount of data, right?
Mm-hmm.
And whenever, if you move your data, let's say you are working with, let's say 2 terabyte of data. Okay. When you hit any job in my Hadoop system, if you start traversing 2 terabyte of data, it will have very high network traffic. It will generate high network traffic, right? You also require huge bandwidth,
Mm-hmm.
right? There are gonna be a lot of IO operation,
Mm-hmm.
right? When you traverse your 2 terabyte of data. Hope you understand what is network traffic, bandwidth, IO, seek
Yeah,
time, disk,
yeah,
seek time,
those
disk
are
time, all those.
so that's occurs when if you trying to move data, it will slow you down or something.
Correct. Absolutely correct. Okay. So in my Hadoop system or the big data, I have a huge data. So do you think we should traverse this much data? Is it good or bad?
Is this bad?
Right? So that's why Hadoop come up with a solution and mention that instead of moving data, why can't we move our computation or the process or job,
Yeah.
right? Let the data resides itself. I don't want to move the data. It's a huge data. It will cost me a lot of network traffic, bandwidth will be utilized, a lot of IO operation, disk time, seek time. Okay. So what it do? Instead of data, it will start processing the, moving the process. Okay. So let's say this for the 20 terabyte, this contain 60 GB. Okay. This contain, let's say 50 GB. And these two contain 40 GB. Let's say 40 GB. Okay. So what my system did, so it will spawn up 4 jobs. Okay. Let's say job 1, 2, and 3, like that. So job 1 here, job 2 on second node, job 3 on third node, and job 4 on fourth node. Right. So it will only move the jobs. not the data. So that's why it will not generate very huge network traffic and all. So with process movement, I can say less network traffic. Okay. Less bandwidth and less IO. Clear on this? So that's how,
Yeah.
that's why my system will get optimized. Okay, and this is for the data movement. Understood? Any question, doubt here?
You good?
I hope you are pretty clear on this.
Yes.
Okay, so that's called as a data locality. Okay, so shall we move ahead?
Yeah.
Just ask me anything. Don't say go. Whenever you feel any question, doubt, just ask. That's why you are in this training.
Yeah, that should be fine.
Good. Okay, so moving ahead. So Hadoop distributed file system. Okay, so definitely what is meant by distribution? I'm not storing my 2 terabyte on one node. I'm storing my 2 terabyte on 4 nodes.
Different nodes.
Different node, 4 nodes. I break my data and storing into 4 different nodes. So that's called as a distributed storage. Okay. And target toward many read of file stream. Okay. So for this, just remember, because Hadoop is a OLAP system. Okay, that's why it work on WORM, worm. Okay. Worm means write once, read multiple times. Read multiples. Okay, so what Hadoop says, I'm good if you write once on me, but read operation you can do many number of times. Okay, clear on this?
Now, can you repeat this? I
Okay.
think
Okay. Okay.
I clicked away and I didn't hear you on this.
Oh, okay. So Hadoop is a OLAP system, right?
Yeah.
So for OLAP system, what we define, my system should be write once and read multiple. It means that my system says that you should write less on me, but you can read as many times you want. Clear?
Yeah.
Hadoop don't say that you write again and again. It's not effective.
Okay.
Okay, it's not advisable that you go and write or do the rewrite again and again on the Hadoop system. It's not advisable.
Okay.
Okay, your performance, your system will be degraded in that case. Okay, your write operation should be less as much as possible. But when it's go to the read operation, then read operation you can do any number of times and it will give you the best performance. Clear on this?
Yes.
Yeah. That's why, see, try to relate all the things, try to connect the dots. That's why Hadoop read are faster and write are slow. Sequential. That's why we say write once and read multiples. Just now we have seen, right? Okay, so try to connect the dots. Okay, clear on this? Okay, so shall we move ahead?
Yeah.
Okay, obviously write are costly. That's why it is not advisable also to do it again and again. Okay, write are costly, slower, sequential, and it's not a OLTP system. Hadoop is a OLAP system. Okay, now the next, it's a high degree of data replication, 3 by default. So what is data replication? Any idea about this?
Yeah, data replication is for like disaster prevention purposes. You put it in a different places.
Mhm. Right. The same data we are keeping at the different places. So data replication is nothing, making copies of your same data. That's called as a data replication. Okay. In Hadoop system, we are making 3 copies by default,
Mm.
but we can also change this number. It can be 1, 2, 5, 7, 9, anything, up to you. But by default, Hadoop provide you 3 replication factor, means 3 copies of data you wanna have. Okay, clear on this?
Yeah.
Okay. Now, the next is large block size. Data locality we have covered. The next is block size. It's a 64 MB or 128 MB block size. So we can have 64 MB or we can have 128 MB of data also. In Hadoop 2, we have 128 MB of data block size. Do you know what is the general block size in our normal system?
I'm not sure.
It's only 4 KB.
Oh,
That's it. Would you like to think why in Hadoop we have 64 MB of block size, that much use?
yeah. So that we can have, you know, large in big data. We have like large data, so we need more block size.
That's okay. But what benefit you will get? Let's say if you want to store, let's say 100 MB of data. Okay. So 100 MB of data means, so you will for Hadoop system, you will require how many nodes, how many block you will require for this
On which one?
on Hadoop?
On Hadoop, we need 2.
2, right? 64 plus 36,
36. Yeah.
right? But when it's come to the traditional system, how many number of blocks you need?
We need 25.
Oh, why 25? It's 4 KB. Block size is 4 KB only.
Yeah. So we need 25 block. 25 by 4 is 100. Oh, KB. Oh.
KB. It's in
Oh,
thousand actually. Something
yeah.
into thousands,
Yeah.
right?
Oh, shoot. Yeah.
Okay. So here we require only 2 blocks. I'm writing BLKS. Okay. Here I would require 1000 of blocks. Now, any guess what benefit I will be getting with Hadoop? Using 2 blocks or using 1000 blocks?
Yeah. So read will be faster.
Yeah, absolutely. Okay. A very generic question. Managing 2 blocks is easier or managing 1000 of blocks is easier?
2 blocks is easier.
Yes. As a nutshell, 2 blocks is easier. So that's why we go with high block size.
Okay.
Okay. And why, what is the benefit of 64? Why 64? That we will see in our HDFS. Okay. Slowly, we will go into deeper. Okay. Clear on this?
Mm-hmm.
Okay, let me help you to understand this program diagram. Let's say the same 64 you have, and here you have 36. Let's say 2 block. I hope you understand the block. What is block? We talk about the blocks, I always blocks, but what is block? How you define the block?
This is just a space.
Yeah, it's the same. But how you exactly define the block?
A space on the like on the on our drive.
Yeah. So how we define it exactly? It's a minimum physical storage on desktop. Remember like this. It's a minimum physical storage because we gonna have 2 type of storage in Hadoop. One is logical storage and physical storage. So block is a physical storage on disk minimum. Okay. So let's say this is my block 1. I'm writing this as a B1, let's say, and this is my block 2. Okay. B1 is handling my 64 MB of size. MB. Okay. And B2 handling how much?
36.
36 MB. Okay. So that's how I'm going to have two blocks for 100 MB of files. Clear on this? Okay. Now, let's talk about the replica also. Okay. How replica works? So replica work for each of the blocks. I'm going to have a copy. For this B1, I will have copy this. Okay. For B2, I will have copy this. Okay. Now my default factor is 3. So I should have a 3 copy. So it's a 1 block again, and this is a 1 more block. So for this, I will have this block. And for again, I will have a copy of this block into another node. Now what I have seen, I have a same set of data into 3 different nodes. Right? Do you see that?
Yeah.
Block 1, the same 64 MB I have stored in data node 1, data node 2, and data node 3. Why we have done this? Due to the replication factor. Okay. Clear on this?
Yeah.
Okay. Now, what is the benefit of it? Let's suppose because we are using commodity hardware, right? They are cheap hardware. Okay. Suppose in any way your node 1 goes down. Okay. So, but if you haven't make a replica of your blocks B1 and B2, you will lose your data completely. Right? Let's say your node 1 is failed. It's sorry, it's destroyed. Okay. If you have not created the replica, you will lose your data. Correct? But if you have taken the replica, so you can get your data from node 2 or node 3. Clear? So that's why we used to say it's used for disaster management. Clear? Any question, doubts so far?
No.
Okay, are we good?
Yeah.
Good. Okay. Now the next one is called as a rack awareness. What is rack awareness? Any idea on this?
No, in a data center, rack is a place where you keep your infrastructure.
Mhm. Very good.
But on Hadoop, I don't know what rack awareness is.
Okay. So rack awareness says, in simple word, it's simple word, at least one copy of data should be in another rack. Read this line again, and then I will explain.
Rack awareness, at least one copy of data should be in another rack.
Okay, that's called the rack awareness. Now, how rack is defined? So rack is nothing but rack is actually the combination of data node called as a rack in Hadoop system.
Combination of what?
Nodes.
Oh,
So this is my rack one. So my rack one contain two nodes, node one and node two. Okay, and this is my, let's say, rack two.
okay.
Rack two contains node 3, 4, and 5. Okay, clear on this? Now, how you can assume this? Suppose you go to a hotel. In hotel, you have a complete building, then you have the floors, then you have the room. Right? Okay, I hope you understand what is rack.
Yeah, I understand now.
Okay, now, what rack awareness says? At least one
But I don't get the hotel logic though.
Sorry, come again.
I don't know what the hotel logic you mentioned.
Okay, I tell you why I mentioned hotel logic.
But I mean I understand the way you explain it here. That should be fine.
Okay, hotel logic means why we have a different unit of storage over there, because in hotel you have a one building. Okay, under the building you may have multiple floors. Each floor have the multiple rooms. Correct? Okay, same things will apply here. Just to relate something so that you can remember this. Okay, I will tell you how it is.
No,
Okay.
that should be fine. It's just I understood the rack idea.
Okay, okay, good. So it says one copy should be into another rack. So if you notice here, B1 and B2, okay, I have kept into one copy kept into rack 2.
Okay.
Okay, it may be the possibility I have one more node here. Maybe that's quite possible. I have, let's say, node 6 here. Okay, and I can, the third replica I can have in my node 6 also, right? But I should not do that. I should do that at least one copy of my data should be into another rack. Okay, I should not keep my replica into the single rack, not onto the 6th node. Why so? Why so? The reason, suppose something goes really worst and you lose your entire rack. Okay, if you kept your entire data into a single rack, again you will lose the data. Right? But if you make a copy of your data into another rack, still you have the data on node 3 into second rack 2. Hope you got the point here. Hello.
Hello, what is I didn't hear you this one.
Okay, but I'm saying, suppose if your rack 1 goes down, suppose something really happened worst, something disaster happened, and you completely lose your hardware rack. If you keep everything into one single rack, you will lose your blocks forever.
Yeah, so everything will be gone.
Correct. Okay. So to overcome this, suppose at least one copy you put into another rack.
Yeah.
So, but still you have the data. Even though your something really goes wrong, disaster happen, you lose your entire rack. But still you have the copy into another rack, and you can retrieve your data. Okay.
Yeah.
So that's the concept of rack awareness. Clear on this?
Yeah.
Okay. So now one last thing. This entire called as a cluster.
Okay.
Okay. So how we learn here? We have cluster. Under the cluster, I have the rack. Under the rack, I have the node. No, under the node, I have the blocks. So that's 4 level storage I have. Cluster, rack, nodes, and blocks. Okay. Why I giving hotel example? Building, floor, and room. Right? The units are getting at the lower level. I have 1 cluster, 2 rack, 5 node, and n number of blocks. Okay, so that's how the physical storage I have in any building or hotel room building. Right? I have one building, multiple floor, and one floor have multiple rooms. Okay, clear on this? How is the this complete infrastructure of my Hadoop system? Clear? Any question, doubt so far?
No, no doubt.
Okay, all good. Just have a look and ask me if you have anything.
No, it should be good.
Okay, good luck. Okay, fine. I think that's okay for today. Okay, tomorrow we will start. Okay, tomorrow we will start with Hadoop component like MapReduce and HDFS. Okay.
Okay.
Okay, we will see the very high level different component in Hadoop. Okay, I think today we can wrap up now, little early today.
Okay.
Okay.
That's fine.
So far, any question?
No, it should be
Okay.
good. Yeah.
Okay. Hope you understood this correctly. You will. It looks
Yeah, it
interesting
should
to
be
you.
fine with this one. Thank you.
Okay. Cool then.
All right. See you tomorrow.
Okay. Okay.
Bye.
See you in the next question.
Bye.
Bye.